12.7, exploring similar solids. So what we have similar solids, or two solids of the same type with equal ratios of corresponding linear measures such as heights or radii. So remember, when we say the word corresponding, what we mean the same. So if we look at our 7, the corresponding side length was 7 would be 21. So if I was going from, we'll call this figure A, and we will call this guy figure B. So if we're going from A to B, so we have 7 over 21, we can reduce that down to 1/3. And so the corresponding side length with 7 is 21. Corresponding side length with 5 then would be 15. And the corresponding side length with 3 would be 9. So each and every one of those is going to have a scale factor of 1 to 3. So this is our scale factor right here, 1 to 3. So if two similar solids have a scale factor of A to B, then corresponding areas have the ratio of A squared to B squared, and corresponding volumes have the ratio A cubed to B cubed. So if we look at each of our individual parts, we talked about this back in similar figures back in chapter 11 with areas of figures, and we said that when we're comparing, when we have similar figures, we had to square the area. And now remember, I said we get back to volume. Well, here we are. Remember, the volumes are cubed, so I'm looking down right here. Volumes are cubed. Okay, so if you have your parts, which are here, so if you have your parts, if you're comparing parts to volumes, then you have to cube to make them the same. So let's go through this one. It says, tell whether the given right rectangular prism is similar to the right rectangular prism shown at the right. So we're going to start with figure A. So they're going from 4 to 8. So we're starting with the figure at the right. So they went 4 to 8. Okay, we're going 4 to 8. Those are the lengths. So 4 to 8. And those have a scale factor of 1/2. The next one that we're going to do would be the width. So we start here with the figure at the right. So we're going to 2 to 4. So 2 to 4, that's also 1/2. And then finally we're going to get the heights. And so the heights are 2 to 2. So here's the height here, 2 to 2. That has a scale factor of 1 to 1. Therefore, that is not a similar figure. So these two solids are not similar because the ratios of all the corresponding parts are not equal. So what I mean by all the corresponding parts, the 1/2 are the same, but this guy right here, the 1 to 1, that is a different ratio. Therefore, they are not similar. So let's look at B now. I'm going to erase the ink up here. I'm going to erase this on our figure at the right, and I'm going to change to the color green. So we're going to use green. And so for this one, it says now they're going from 4 to 6. So we're going from 4 to 6. So 4 to 6, that has, we can reduce that to 2/3. The widths, they're going 2 to 3. So this 2 to 3. So that looks good. And the heights are also 2 to 3. So based off of our answer on number or letter A, we have 2/3, 2/3, and 2/3. These are all the same ratio, therefore they are similar. Okay, if they have equal ratios, then we know that the two solids are similar. Alright, down here it says use the scale factor of similar solids. The cans shown are similar with a scale factor of 87 to 100. Find the surface area and volume of the larger can. Okay, so let's start with surface area. So I'm going to change back to red, just a little bit easier for you guys to see. So we're going to start with the surface area. So this is surface area. And I'm going to come over here and I'm going to come down at the very bottom. I'm going to fill in this chart. Remember the parts? The parts. So if we look at our parts, it tells us that they have a scale factor of 87 to 100. So we know this here is 87 over 100. So that would be like your A to B. So your A to B. That's the same thing right there. So perimeters, remember, that's the same. So perimeters are the same. So we have 87 over 100. If we're looking at the areas, which is what we're doing, so surface area counts as areas. we'd have to do 87 over 100, and if we have areas, we have to square those, okay? We have to square those. So when I come up here, what I need to do then, if I'm looking at areas, so we're finding ratios with areas, I have 87 over 100, but since it's an area, that means that I need to square these guys. So I would square this 87, I'd square my 100, and I'd set that equal to, well, let's look at our parts here. It says that the surface area of part 1 is 51.84, and that's inches squared. So this on the top would be 51.84 inches squared. And on the bottom, we would have x, and that would be in inches squared. So the 51 goes on top because you can clearly see that 1 is smaller than 2. And since our scale factor is 87 to 100, that would mean that this guy is 87. He would be the scale factor 87 here. And this can is the 100. So this is the 100, and the big one's 100, the little one's 87. And so now this is just an algebra problem. We cross multiply and divide. So at the very end, we should get x is equal to 68.5 inches squared. So that's surface area. Now if I come down here and I'm looking at volumes, remember if we have volumes, we have 87 over 100 still, because that's our scale factor. 87 over 100. They told us that up here in the problem. Now what we would do with the volumes, since we have 87 over 100, we need to cube those. So we need to make sure we cube those. Now I'm going to come over here and I'm going to look at the volume. So I have volume, and I'm going to be comparing these volumes. Volume. And I have 87 over 100. And I set that equal to, it's going to be 28.27 all over x. And with these guys, now since we have 28.27, that's inches cubed, our x is inches cubed, we're comparing volumes, so we need to come over here to our scale factor and we need to cube these. So we need to cube 87 and cube 100. Once again, now from here we just cross multiply and solve. So x is going to equal 42.9 inches cubed. 42.9 inches cubed. So these are the surface area and the volume of the larger can. Alright, moving to example 3. It says the pyramids are similar. Pyramid P has a volume of 1,000 cubic inches and pyramid Q has a volume of 216 cubic inches. Find the scale factor of pyramid P to pyramid Q. And the way this one's going to work here, so they told us that pyramid P, so we're going to go from P to Q. It tells us that in the at the end they want us to go from P to Q, and it tells us the volume. So the volume of this guy is 1,000. So the volume of P is 1,000. The volume of Q then would be 216. So these are not equal to P to Q. What we actually have is P cubed to Q cubed. So this is our volume. Remember, when we're doing a volume ratio, we have to cube those. So we're starting with the cubed. So if we have a cubed, how do we then go back to the scale factor? Well, what we would have to do, I'm going to bring my 1,000 over 216 down here. We did this back in an earlier section. We had a cubed, and when we have something cubed, so x cubed or anything cubed, we have to take the cube root. So on this guy, what I need to do is I need to take the cube root. I showed you guys how to put this into your calculator. So what you do is you distribute that cube root to the top. So cube root to the top. And I'd also distribute the cube root to the bottom. And these two numbers are perfect cubes, which means they're going to come out to be whole numbers. So you're going to get 10 on the top and 6 on the bottom. At this point, you could stop. However, I would suggest that you reduce it all the way down to 5/3, so 5 over 3. This is our scale factor for P to Q. So we were given the volume So the volume scale factor, so that means we had p cubed to q cubed. So to get back to p over q, we had to take the cube root of 1,000 over 216.